believe that there are a whole bunch of reasons why having everything completely on device is really useful. And I want us to kind of push the boundaries and just see how far we can get. Like, how much of a useful system, how many problems can we solve with no network connectivity?
Software's eating the world, but AI's eating that too. Ship, learn, fix, that's how we get AI right. Look at your fucking data, keep that quality tight. Out of the lab, into the field, time to deploy. Real world problems, real solutions, that's what we employ.
Welcome back to How AI is Built. This is Nicolay, and today I'm talking to Pete Warden, who is the CEO of Useful Sensors and one of the all-around goats when it comes to AI on embedded devices. And I'm really excited for this podcast. He's also the author of the TinyML book, and he spent years at Google building speech recognition systems. And his philosophy or his point of view is especially like while everyone is racing to the cloud, a really interesting opportunity is emerging to make AI work completely on the device without any network connection. And in this episode, we're going to be talking about that LLMs, for example, can actually do things. So they don't really know anything about real world actions. And because there's nothing in the web corpus that knows how to connect text to the real world. And this is why often agent demos are stuck in booking flights instead of controlling your home, for example. And the second part we're going to focus a lot of time on is like skipping the text and going straight to the intent. And he has built a lot of interesting sensors which detect intent for fuzzy things. So, for example, you don't always have to say like, "Hey Alexa," to trigger the AI to spin up, but it's, for example, gaze detected. It's like based on certain keywords, or it automatically detects when you actually want to speak to it. And I think this podcast overall is really interesting, even if you don't have the goal of doing embedded stuff. I think it always helps. Like, how can we actually work on AI with like heavy constraints, and what can we learn from it, which then often applies in other areas as well. Let's do it.
By the way, do you think it's like the Riverside is like an interesting pattern we are seeing more and more of, like using more of the user's device to do some computations, some storing, some syncing?
Exactly. I mean, I mean that's a whole nother topic. I feel like um, there's so much stuff that makes sense to do on the edge that you
Yeah.
can combine with cloud, um, and I feel like people have just kind of forgotten that like Gmail and Maps and everything else, like the magic came from the combination of the cloud and the client side, not just running everything on the cloud. So anyway, that's another rant for another day, I guess.
Yeah. It's interesting. I'm working on a problem right now, which is like in the end AI, but like people underestimate like for like long conversations and streaming stuff, like network connections are really like not as reliable you would want them if you want like highly accurate output. So often like caching stuff client side and then just sending it in bulk at the end as well, like often
Yeah,
lets you avoid a lot of issues.
no, definitely.
Nice. By the way, what do you think is going wrong at Apple Intelligence? I think like you're one of the few who has like the perfect insight into what is the
Yeah,
issue.
I mean, I think that there's like Apple's so design led. So Apple is used to having um, basically the ability for the designers to yell at the engineers to make something work. And AI is still so early that no matter how much yelling you do at engineers, um, it's not going to do the things that Apple wants it to do, in terms of just being so, they want really high accuracy. They want it to, you know, not screw up in embarrassing ways. Um, and, that's just not where AI is at now.
Yeah, it's. I'm looking forward to them actually becoming a player because I think like they're a lot of AI stuff which is happening is rather like design work as well, like collecting
Yeah.
user feedback, getting the user to like give valuable feedback, improve the system, but also like it's imperfect, so you should be collaborating with the user instead of like just like, hey, that's the correct answer.
Yeah, exactly. And the thing that I always come back to is the most genius feature of Google search results is the little snippet they show, because that means they only have to get the correct answer in the first three or four results that you see. And as long as you can just scan those clips, you can pick out the absolute right answer, and they just have to be kind of in the ballpark. Um, so that kind of collaboration with users, so that they do the final, bit of work without thinking about it. That's a really good design pattern for a lot of this stuff.
Yeah. What do you think in the direction that, because a lot of the stuff they're doing as well is around LLMs, is there an issue that you can't really get a lot of like different task specific model on the device that would actually serve all the different interactions users have with like Apple devices?
Well, I think this is kind of leading on to some of the speech to intent stuff, but I think people are kind of fooled a little bit by LLMs because they're really good at taking in text and then generating answers in text, but they don't know anything about real world actions. So, if you ask an LLM to turn on a light, there's nothing in all of the web corpus that it's called that knows how to connect turning on a light to just kind of you know, sending a pin high or something like that. Like it kind of fools us because we talk to them and they seem like super intelligent. You can ask it all sorts of questions about turning on a light and like what a light bulb is and all this sort of stuff. But that's just because there's lots of text kind of connecting those ideas. But there really isn't a good training set for going from a command to taking an action in the real world, even an action as simple as turning on a light. So I think that that's part of what they're running into as well. And that's why all these agents have, demos are just about booking stuff on websites, because that's kind of a very text heavy approach, and it relies on, you know, pages full of text and maybe some API calls that are documented using text, but it's all still fundamentally stuff that's on the web. Once you start getting off the web, trying to do things gets so much harder.
Yeah. Can you maybe quickly define like what speech to intent is? Because I think this was one of the like really most interesting blog posts you had on your website.
Yeah, and it's really this idea that you want to say something and then you want to have something happen in the real world. So think about it with, and sorry if everyone's devices go off, but if you say Alexa, you know, sort of, play Baby Shark, then what has to happen there is Alexa has to understand, oh, you're asking me to play music, and Baby Shark is the name of a song. And that's actually not too hard to do it in that case, because you just say, oh, if somebody says play after the wake word, then you just look at what the rest of the sentence is to use that as a song name or an album name or artist name. But it gets really hard once you want to do either more complex things or you want people to be able to use natural language. Like if you said, hey, Alexa, I want to hear Baby Shark, if they hadn't programmed in, I want to hear is the same as play, then it's not going to know what you're asking it. And I think a lot of the reason that almost nobody uses these voice interfaces, whether it's Alexa or Siri or OK Google, um, is because they really don't understand us in a way that a person understands us. Like, we can say lots of different ways. There are lots of different sentences that you could say to somebody else to get them to put, to play a tune, to play a song. Um, Alexa and these other devices, they only understand a few of those natural language sentences. So it becomes this guessing game of trying to figure out exactly what form you have to say something in for these devices to actually do what you want. And the whole world of speech to intent is about really trying to expand the number of ways and all of the different possible sentences that you could say to make something happen, that a person would understand, and try and make it so that our machines can actually understand more of those too.
Yeah, I think like part of the complexity is like each simple sentence already is multiple steps. Like you first have to recognize you're powering on now, like by the trigger word Alexa, which is already one AI you have or like one model running. Then
Yeah.
you have to recognize like what item are you taking an action on? Like
Yes.
is it the speakers or like what room is another example, and then actually what action to take. Is there like a set of components you're thinking about when you're building like a speech to intent system?
Yeah. Uh, and one of the interesting things is that we often break this stuff down into kind of individual models, but we actually lose information when we do so. Um, and one example of that is uh, when you uh, when you say a sentence. The typical way to handle it is you convert that sentence into text so that the computer can more easily operate on it. Um, but the trouble is, when you do that conversion into text, you don't always know exactly which words the person is saying, because there are a lot of words that sound similar, like there and there, which sound exactly the same but have different meanings, and there were tons of those. And so the speech to text part of the pipeline has to make a decision on which ambiguous words, like how they're actually spelled and what their meaning is, and then they get fed into traditionally they get fed into a, okay, how can I make sense of this sentence? But you've lost a bunch of information because um, you don't have all of those alternate meanings of the sentence that could have different spellings that have the same, same word, um, you know, spoken, that can mean multiple different things. So there's actually some of the more successful approaches just go directly from, like, have the speech to intent in a single model. So within a model, it never goes down to just plain text. It actually turns it into an embedding kind of partway through the model that represents the different variations of that sentence that could possibly exist with kind of similar sounding words. And then you match on that to do the intent, uh, as part of the same model versus kind of trying to break it up into chunked pipelines. And that's a theme we see across a lot of AI in general, is that we start off with multiple models in a pipeline because it's easier for us as people and as engineers to kind of build things that way. But we start to realize that actually if we just cram it all into one big AI model, um, we end up getting better results.
Yeah. So everything is again unbundling and bundling.
Yes.
Um, how do you see it? Like, I think in Apple, especially, like you have a shit ton of actions you could take. Like, it's nearly endless, and also like the different interactions you could take. How large can the action set be when you use like one large model and don't decompose it to basically orchestrate multiple models which are branching off?
Yeah, and the way I actually normally think about it is um, you try and figure out what the actions that you might want to take are, which are actually a lot, that's a much smaller set of actions to take than kind of all the possible actions in the world. So for a smart speaker, you might say, hey, people want to play music, they want to set timers, and they want to ask random, do random searches on the internet. And that probably covers like 90+% of all the ways that people use smart speakers. So then you've actually got this much smaller universe of things that you're expecting to hear. And because somebody's explicitly triggering, in this case, they're saying a wake word, like Alexa or something like that. Um, as an aside, in the future, I'd like to just do gaze detection. So you just look at something and then start talking to it. I think that's more natural. Um, but you know that somebody is talking to this device, and the person knows that this device only does a few things. So you can be fairly generous in kind of interpreting what they're saying, expecting that it's going to be one of these, limited set of actions. Um, and, to get technical on that side, what we often do is we create embeddings um, for sentences. These represent, you know, vector representations of um, what the sentence means, and we create embeddings for like maybe one or two or three canonical ways of asking for somebody to play a song, for example, and then we actually compare the um, the sentence that's come in against the embeddings of the actions we know in this kind of crazy n-dimensional space. But you can just think of it as like as a 2D space. You just kind of say, oh, playing music is over here, doing searches is here, and setting timers is down here. And so you sort of look to see if the sentence that you've got, its embedding is close enough to one of these kind of like known action points. And if it is, then you say, okay, I think they're asking me to set a timer.
Yeah, I'm really curious about like the other 10% of the actions as well. Do you use something like fallbacks? So do you always have like an other embedding, which basically catches the outliers, which don't belong into any group, and route them to something different, like an LLM?
So that is a big, um, yeah, that's a big topic, because honestly, I've gone back and forth on this, because this even comes up with speech to text, because often people say, oh, I only want to recognize 10 words. But the hard part is there are, hundreds of thousands of words that you don't want to trigger one of those 10 words. So you end up having to kind of recognize all of the words just to be able to be sure that it's one of your 10 words that you want. Um, and in the past, I have trained with this kind of notion of a other, category, which I just shove all the, hundreds of thousands of other words into when I train with the, the 10 words that I want. Um, and it's okay. It's not great. Um, the, the holy grail is really, I think, like you said at the start, saying, okay, there are all these different possible actions, actually create this universal action understander that will be able to kind of tell what action you're asking for and then only trigger on the ones it knows how to do. And then,
Yeah.
like you say, hand off others to maybe some other system.
So in the end, it comes down to understanding the user, the task, the subject matter, and actually mapping that onto concepts.
And the big thing is it's actually understanding the world around us. Like that's the thing that's missing from LLMs. You know, they can talk about the world around us, but they have no idea that you have to kind of flick a switch to turn a light on.
Yeah. Do you think LLMs are the easy way out? Because they are good enough to be used in a lot of contexts, but not really good enough to be deployed into production.
Well, I think it's been it's been funny because from my perspective, I've seen people kind of underplaying the impact of AI. For the last, for a lot of the last 10 years, it's been kind of treated a bit skeptically, and then LLMs came in, and I think people are actually overestimating what AI can do because you've suddenly got something that can talk to you. You can actually have conversations with, and that feels very intelligent, and it really it really helps for a whole bunch of tasks. Like coding. Anything that's around generating written text. All these image generation things. Um, Anything that can be expressed in terms of something you'd find by scraping the web and being able to kind of make those connections. Um, but there, that is kind of pretty seductive because you think, okay, things are almost solved. But there's this whole kind of interacting with the real world component of things, which I think I said at the towards the start. That's why all of these agent demonstrations are doing things like booking flights, because that's something that those are actions that can be understood, or calling APIs, because then there's text that kind of corresponds. There's comments in the API or the docs that tell you how to use the API, and that's all on the web. So LLMs can understand that. I think the next challenge is really going to be, okay, we've got these beautiful machines for taking tons of content and turning it into useful stuff, but we need content that's beyond the web corpus to be able to actually tackle a lot of the problems that we care about.
I'm really curious on your outlook on the world, whether you expect like the multimodal models that are emerging, which are trained on like vision, audio, text, to be way better at world understanding but also whether you expect them to be better at world understanding than, for example, a model you train yourself on like one specific action set you have and you deploy on your enterprise.
So I'm really bad at predicting the future, I guess is one thing.
Everyone is.
Yeah. um, so, with that out of the way, I've still been really struggling to find, like, LLMs. If you ask them, oh, what does flicking a light switch do? In language, they'll tell you, oh, that turns on the light. But there's no real connection to the actual action that you're taking in the real world. Now, if somebody can figure out how to take that kind of textual information and, I've thought about things like using YouTube videos. Maybe there's dialogue where somebody says, hey, I'm going to turn on a light. You could do like pose analysis of the person kind of touching the light switch, and then you could see that the room lights up. And maybe with some data coming in like that, we could actually do a much better understanding of the real world. And OpenAI's and Anthropic and everybody else, they employ tons of smart people. So I'm not going to say that we couldn't bootstrap our way into understanding the world from this primarily like text and image corpus that we're training everything on, but I haven't seen a way to do it myself, which is why I'm focused on, okay, let's let's take an approach which will at least work better than kind of the non-AI approaches that most current assistants are using.
Yeah, I think part of the complexity is actually you have like different objects, the state of the objects, which the model has to recognize. Then the other object, which is the light switch, you have to link it in a relationship. And then you also have like all of the other stuff in the environment, which is just confusing. And then you have the actor, which is taking the action.
Yes,
And
exactly. I mean, one of the things I've thought about testing this idea with is um, one of the great things about the internet is there's tons of dog videos. And so if you actually have a pose model of a dog and you listen to what people are saying to their dog and then you see what it does, then that might be a kind of uh, a sort of semi-supervised, unsupervised way of actually learning what you should do as a robo dog in response to what people are saying. Um, I would do it with cats, but because there's even more videos of cats, but cats never do what you say, so it's not particularly useful.
yeah, I'm really curious on like the bigger picture of this. Like, how do you also in your training data and then once it gets to the real world, how do you handle all the noise, the accents, like multi-speaker scenarios, things like that, especially like in training, but also during inference, because you will never hit all of the different edge cases.
Yeah, um, funnily enough, a lot of the problems have literally, for in the speech to text side, have just been solved by throwing more data at the problem. Like for a long time, when I was at Google, um, their speech to text models were like the crown jewels. They were held very tightly. They were really seen as this massive competitive advantage because it had taken, over a decade, hundreds of engineers, some, really cutting edge research to create those models. And the same went for sort of Apple and Amazon. Um, then OpenAI came along with Whisper, and they demonstrated that by taking 600,000 hours or 800,000 hours of audio with some transcripts, you just feed those into the hopper, and you get out something that's actually up there with the best models that um, you know Google and Apple and Amazon have. So for a lot of stuff, just throwing more data at it has worked. There were still some problems, like you mentioned the multi-speaker stuff. Um, that's still a bit of a head scratcher trying to do like diarization, as it's as it's often called. Um, but most of the noise and everything else is actually solved pretty well just by throwing more data at it.
Yeah, and ho- when it comes to, for example, the multi-speaker stuff, how would you actually decide what do I actually want to, like, for example, filter out? Like, I'm adding pre-processing steps before I put the input into my model, or what do I actually just try to train out through more data?
So the first way I try and do it is actually if I can use other signals, like even something as simple as like somebody pushing a button to talk. Like if you can do that, then it simplifies the problem drastically. If you can do something like using a camera to tell when somebody's looking at the device, and there are ways that you can essentially do lip reading um, to filter out what everybody else is saying. Um, there's a great Google paper called "Looking to Listen" at the cocktail party. which I can send you a link to, that uses that kind of vision, multimodal as we call it now. And yeah, otherwise it really becomes like a UX problem with this stuff, because if you're having a conversation with somebody else, that probably means that you're not wanting the device to do stuff. There could be scenarios where you're trying to collaborate on something with somebody, and you both want to be recognized, but it becomes this question of, okay, there are multiple voices here. What does this mean for the actual user experience? Like, what's the intent here? What does somebody want? So yeah, lots and lots of stuff there.
Yeah, it's I I'm really torn on that stuff. Like always, like what to put into like filters, pre-filters, pre-processing steps, and what to try to train out. I think it's like one of the biggest questions in most AI problems you're tackling. And I don't think you can come up with any good rules. You have made in a blog post a comparison of quantization to basically noise in the training data. Can you maybe
Yes.
quickly explain that train of thought?
Yeah, so one of the things that surprised me very early on when I was working with neural networks is you can almost shoot them with a shotgun and they kind of keep on going. They're very, very robust to all sorts of noisy inputs. That's one of their big qualities. But what's even more surprising is that you can quantize and reduce the precision internally. And the only way, and it still works, and the only way I could kind of justify that in my head, and I haven't seen any good kind of academic papers on this, but these networks are trained on so much data that they really have to be able to learn to filter out noise. And then when you start reducing the precision of their internal computation, um, as long as you don't have a bias that's sending the values, in one direction or another compared to the original kind of float version, um, it manifests in a very similar way to a little bit of noise being added at each step. And because these networks have been trained on so much data and have managed to kind of find ways to actually generalize and pull out the real signals from all this noise, they just kind of, they've got four-wheel drive. They just ride over all of these minor bits of noise that you throw in because of quantization.
Yeah, and maybe to give people a little bit of like how far are you quantizing? Like what are the like target sizes of neural networks when you actually want to go on end devices?
Yeah, and there's been this like renaissance of quantization with all of these large language models, and often they get down to like 1 bit or even like crazy compressions that actually result in slightly less, less than a bit. Um, I usually aim for 8 bits for most of my models, because that's an easy data type to compute with. Like, it's very hard to do compute on 2 or 3 bits or even 4 bits. Not many processors have instructions for those, but if you can use 8 bits, there's tons of SIMD extensions and stuff you can use for that. Now, what's interesting in the LLM case is a lot of the quantization is just happening on the weights. So you're still doing calculations in some, you might have 1 bit weights, but you're still doing calculations, accumulating them in like higher precision as they're sort of being used in the network. I find it really interesting that we can get down to those sorts of levels of compression, because I think in my experience, that implies that there's a lot of redundancy. It's like if you've got a gigabyte file and you know gzip it, and it turns into like 4 megabytes, you probably know that that file has like just lots of zeros or a lot of like repetitive content because it will compress down so small. And that's my kind of intuition with a lot of these large language models that's been kind of, we've seen with some of the new models that have come out of China that they can actually go a lot smaller without losing much in the way of accuracy.
Yeah. Have you read the paper on the lottery ticket hypothesis?
Yes, yeah,
Which is,
that's yeah. I was going to say that's really interesting, and it has some ways that you can actually test that idea as well. Um, and I honestly haven't dived deeply into that, but that matched my kind of experience and intuition.
yeah. So maybe to quickly catch up, it basically just says that inside of a large neural network, you can find a sparse subnetwork which basically achieves an identical or very close performance as the original neural network. I think the only issue was they faced is actually like identifying that subnetwork is really hard and not really computationally efficient.
Yeah.
Um, but they had a proof that it exists, which
Yeah.
basically has the same like in the end assumption in the end that goes into it, that there is a lot of redundancy in most of the neural
Yes.
networks we have.
Yeah, and that's we're definitely seeing that, and it almost makes me, analog representations also really interesting. An analog compute, because that's another way of just saying, we're going to lose some precision, but um, we're going to, the whole paradigm of kind of the Turing machine that is the basis of our CPUs and even our GPUs, it seems a bit dated when you think about the fact that most of these networks don't even have any conditional branches in them. You're literally, for millions of cycles ahead of time exactly what computations you're going to do, because there's no if input equals X, then do Y stuff. The code paths, the data access, um, and that just seems like it's crying out for something that's doesn't have all the problems. Even the cache is a massive pain because you have to keep tricking the cache into making sure it has the stuff that you'll need, for the rest of the compute. So
Yeah. What are like the different approaches or tricks you use to shrink neural networks? I think there are a lot of different ways to actually do it. What have you seen work best in practice beyond just like weight quantization?
so really, the like a lot of people like distillation, teacher pupil sort of, all this sort of stuff. What I always start with, and this was kind of something I saw a lot of at Google, is just, hey, take your same training data that you're using for a big model and just create an architecture that's smaller and run that training data through it. And a lot of the time, you'll actually get something that's, pretty decent. The degradation with reducing the size of a model tends to be fairly graceful. And so that's always my first advice is, hey, you've got a big model, and as long as you've got the training data, just define an architecture that's smaller and try running your training data through that instead and just see what you get.
Yeah, I think there's like a bunch of different things. Like, there's one really interesting paper which came out by Apple, where they basically went through like paths of how you can quantize LLMs, which is really interesting. Where they just set out a bunch of rules, like when should you quantize, but also like when should you do distillation, when it's better just to train a smaller model from scratch instead of doing distillation, which is also very interesting. Like, this is really interesting, which I want to know. Like, when do you actually distill, and when do you just basically train on the same training data?
I mean, my bias is very heavily towards just. training on the same training data. Like that's my default, um, and that kind of pushes, because what I found is there are a lot more options with like distillation, and that's a whole nother kind of set of hyperparameters and all of this extra complexity that you're adding into the training process that you need to tune and get right. In practice, even though distillation may theoretically get you better results, usually in a given kind of amount of time, um, the best results. You'll actually be able to, you'll be able to complete training the smaller model. It's always trickier to know if you can actually get the distillation working. And part of that, honestly, is just my um, either laziness or pragmatism, whichever you want to call it. But I I want something that is bounded in time when I'm looking at doing a new model.
Yeah, I think like for most people it's probably the reverse by now because it has become easier to do the distillation because like most of the stuff which is out there, like most tutorials, are using distillation. Um, which is
And I
also
and
yeah
I think it's probably, I'm a bit of an old geezer at this point, and so part of it may just be my scars from previous sketchy distillation stuff, and the fact that I'm actually not doing that much LLM stuff. We're actually doing much smaller language models.
yeah. I always have like the default like when everyone's sick I go SAG. Because I think like most people just go with the easy solution. Um, and I always think like it's likely not the one that will work.
No, totally.
Nice. And do you ever train models? Like I think like you can train in a quantized way already, or you can quantize after the training. Do you ever go with like a former like training in a quantized fashion?
I do not, but that may have more to do with the fact that, again, I'm an old geezer who's been kind of doing this for like 15 years now, and um, the quantization during training tools have always been, again, pretty fiddly to use. The other issue I have with them is there's so many different ways of quantizing that it's very hard to match your training quantization exactly against the true quantization that you'll be doing um, during inference. Like even Onyx has a whole bunch of different options for signed, unsigned, exactly how you do the quantization. Um, and so again, just to make my life easier, I stick with something simpler.
Yeah. And since you already mentioned it, like you're focusing on small LLMs, can you maybe quickly touch on like what are you guys building and what are you training, especially in the LLMs?
Yeah, so a lot of it is around this idea of actually helping people interact with objects and do actions in the real world. So that means everything from, we have Moonshine, which is a really small, fast speech to text model that's actually, we've released publicly. Um, and then there's a whole bunch of stuff we're doing internally, both to do multimodal, so vision, looking at who's talking and all of this other sorts of stuff, as well as trying to do the speech to intent.
Yeah, and all of these are LLMs, or what are the different model architectures?
Well, most of them are language models of some kind. I don't know if a 40 million parameter language model is an LLM.
Yeah, so model architectures. Just
Yeah. So um, at this point, I'm actually uh, because I have taken on the CEO role at Useful. I'm a little bit more out of touch than I used to be with the exact internal workings. Um, but my co-founder and CTO Manjanath has done some really interesting stuff with the moonshine, um, around using rope is the term. Sort of a rotary approach to actually doing the encoding and decoding for a transformer model. Um, and the key thing there is it lets us, unlike Whisper, where you have to pass in 30 seconds of audio every time, and you just have to zero pad it if you don't have 30 seconds of audio to process, and then the whole 30 seconds, even if it's zero padded, gets kind of processed by the network. Um, he's actually set up something where you just pass in a variable length buffer of however many seconds of audio you have, and it only does the processing on that. So we have the Moonshine paper out there for people who want to kind of dive into some more of the details there. But I think that's one of the key innovations that our team has actually managed to do in terms of uh, the model construction.
Yeah.
Rope is it's not a technique we invented, but it's the first time I've seen it applied to this kind of voice model.
Do you ever escalate to servers or to remote models which are larger?
We do not, and kind of like you were saying, you like to zig when everybody else is zagging, or vice versa.
I'm not sure.
Yeah. Um, I believe that there are a whole bunch of reasons why having everything completely on device is really useful. And I want us to kind of push the boundaries and just see how far we can get. Like, how much of a useful system, how many problems can we solve with no network connectivity? And a lot of this comes from my experience with IoT, where the first step is, okay, we're going to add Wi-Fi and Bluetooth to this thing. And then the next step is like, oh, okay, what can we do for users with this? And that's a big reason I think why IoT has been such um, a failure, honestly. Um, yes, there were some isolated success stories, but for something that's had so much time and effort and money put into it, it's pretty disappointing. Um, so I'm trying to say, okay, let's look at user problems. Let's try and solve as many user problems that aren't currently being solved by using completely on device processing. And that gives a bunch of advantages. One of the key ones is that it's a lot easier to explain to people what's happening with your privacy and your data if you tell them never leaves the device. It goes nowhere, um, not transmitted, nothing happens to it. Whereas if you look at, my wife was actually installing an update on her Mac, and the Apple Intelligence stuff, it basically said, oh, we keep everything on device except for the stuff that we don't, that we send to the server when we need to. And that's just a really confusing. I've struggled with federated learning for the same reason, because it's basically saying, oh, we're going to keep most stuff on device, but we're going to send some stuff off. And there isn't an easy way to explain which is which or to understand which is which. So that's a big reason why I've been trying to avoid that hybrid approach. Is for anything that's privacy sensitive, you need a privacy model that people can actually understand. And with hybrid, you lose that. Now, there are lots of other reasons to use hybrid. I'm not against it at all. Um, you know, you could have, like, on your speaker, uh, coming back to that example, what I'd love to do is have all of the voice processing happen on the speaker, so that your audio, which is super sensitive, like you're going to be saying things all day, and you really don't want that stuff to be leaked to anyone. It could be embarrassing, could cause harm. Keep all of that audio on the device and just kind of don't collect it. Just kind of respond to what you hear and then never record it. But then, if you want to play a song, like stream that off the internet. Or if you want to do a search, then send just the search query to the internet. But so a lot of my thinking is really around, as you can tell, really about the privacy aspects versus, the engineering aspects.
Yeah. What I'm really curious about is your concepts of like the modules or sensor modules, which are not like as we are used to it, which are sensors, but which are like AI capabilities, which you're basically packing onto like whatever your
Yeah.
consumer wants. Can you maybe explain the concept and also the different types of like sensors that you've already built?
Yeah. And honestly, I should preface this with, in some ways, the kind of machine learning sensors we put together were a failed experiment because we haven't been able to get big consumer electronics or other, companies to adopt them. But the idea behind them is, hey, you want to be able to tell maybe if somebody's sitting down in front of your TV and maybe tell which person it is of your family so that you can show them, uh, what they were last watching. But you don't want your TV to be able to spy on you. Like, you don't want it to either be possibly sending audio and video up to a TV manufacturer's cloud or who knows where else. And you also um, don't want, if your TV is hacked, for people to be able to, you might have your TV in your bedroom. You don't want people to be able to kind of spy on you that way. So the thought behind ML sensors was and is, okay, let's try and like physically contain the information that's really sensitive, um, actually on a single small circuit board that has a camera and a microcontroller built in. Um, and what that does is it essentially acts as a kind of synthetic sensor for sensing something that you can only detect with AI. So, what we did with the person sensor was we had a, one pin on this circuit board which went high when it detected a person. So you were able to use that as a smarter replacement for things like IR sensors in security cameras, or sorry, security lights, I should say, security floodlights, um, so that they would only go off when there was a person there, not an animal or a car going by or something like that. So you can use this AI-enabled device in a traditional analog design without ever having to care that there's actually ML running on this little microcontroller to do the job. Um, and the same thing for the TV use case. Um, you actually pass back a little bit more information then. You pass back, hey, you know, here's my best guess at to which person out of the family, like person 2 or person 7 or whatever it is, out of a limited number of people that it's learned to recognize. I think person number 7 has sat down and, there's 2 other people on the couch with them. But you don't actually ever, even the SOC just never gets any access to the raw video data. So it can't be used to spy on you. You've just got a very clear idea of, okay, even if the manufacturer wanted to be malicious, the physical design is such that they can't get access to the really sensitive stuff. And that can be checked by a third party. Like, I always hope that we could get somebody like Underwriters Laboratory or some other trusted third party to look at this circuit design and say, yes, there isn't a way of kind of smuggling off or secretly recording. There's no network on this little module. Everything's running completely locally. And so you can have confidence that nothing is being, uh, smuggled out or recorded, and there's no sensitive information that's being shared.
Yeah. Have you experimented with loading user-specific configuration onto the sensors? So, for example, with the example of the security camera, that you have like a set of like 3, 4 people which are pre-configured, which can access it, and then you basically load them on configuration, like it's a one-time thing. Load them on, have the representation there, and only they can basically pass.
So one of the other things I really wanted to do was a lot of ML stuff is really fiddly to work with and does require like registration and configuration and things like that. My solution for the, hey, these are the 3 or 4 people who can pass is actually spend like the first week or something like that looking at who's a regular, recognizing the faces that you see over and over again and say, okay, these are the usual people that I expect. And then when somebody else comes along who's not somebody that he has seen before, hasn't seen very often, then you can kind of trigger this, hey, stranger, question mark, output from the sensor. And, depending on the application, the actual rest of the system can take some action based on that. And avoiding that kind of having, another part of the problem with IoT is nobody enjoys setting stuff up. So if you can have a process which is, doesn't require any setup, that's going to be a lot more successful.
Yeah, on that like autonomous discovery, I think like at the moment there's a lot of hype around MCP. I'm not sure whether you've noticed it. Is there something in the like IoT embedded domain as well, where basically devices can expose something like actions that can be taken by other smart devices on them and are automatically discovered and can be acted upon by AI?
Yes, though, funnily enough, my ideal form of this would actually be spoken language between devices. And that sounds a bit wacky, but if you can actually get devices to understand us as people speaking to them, then you've kind of got this ability to understand natural language, which means you can, for example, have if your smoke alarm goes off, your toaster could say, hey, no, it's only me, it's not a fire, and potentially the toaster could turn itself off because things are burning. And as a user, that could be a little bit maddening if everything in your house is talking to each other all the time, but you also get this insight into what's happening. Like there's nothing hidden about all of these communications. You've got a very human understandable view of all of this stuff. So it's slightly crazy, I know, to think about, but that's one of the directions I'd love to try.
Nice. What would you say is missing from the space to make it more successful?
So I really want to see more people thinking about speech to intent. Like it's kind of there's academic work out there, but there really aren't that many people working on it compared to its importance. And if you look at the commercial offerings from, look at Azure or Amazon's SDKs and things like that, they're still using what are effectively kind of like regex based systems to detect what people detect what people want. So the Amazon example, which I remember I looked through, it's for an elevator, controlling an elevator, and it will understand go to floor 7, and it will understand floor 7. But if you say 7, or if you say go to 7, it won't actually understand that. So yeah, it I feel like I'm taking crazy pills sometimes, because I don't think LLMs on their own are just going to solve this, even though it kind of intuitively feels like when you use an LLM that it has a lot of understanding of the world. Um, I think that there's this big gap that I want to see more people researching.
Yeah. Is there any technology that is emerging at the moment that you're really excited about for this?
Ooh, yeah. Um, I love what's happening in the speech to text world. Um, I think that in the last couple of years, I mean, hats off to OpenAI and the team that did Whisper. Speech to text has gone from being this thing that only really large companies could do well and was like a closely guarded secret, to being this technology that anybody out there can really pick up and start doing stuff with. Um, and I think that speech to text models are just going to become, they're well on their way to just becoming a commodity, um, which is awesome because it means that they're going to be cheap and available to anyone who wants to use them. Now, I'm hoping that there are lots. Well, I believe there are lots of ways to retain an advantage there by creating smaller models, by moving up into this kind of speech to intent world. But I really think there's going to be a flourishing of all of these kind of voice related technologies, because anybody can now pick up an open source model which actually does a really good job.
Yeah. And if people want to learn more about what we talked about, what are your top resources to learn about this?
So I would start with Whisper, because that's such a, like, there's going to be an example for it on almost any platform in almost any language. So just grab Whisper and start playing with it and start trying to do stuff. Um, and obviously, I'm a big fan of what we're doing with Moonshine, which is going to come in handy if you actually want to do anything interactive, or if you want to do anything, for example, just running in the browser client side. We have some really cool upcoming support for that coming out. Um, and also running on really constrained devices, things like the Raspberry Pi, and even we're looking at going down to true microcontrollers. Hopefully, as we try and cram that in. I've also I teach a class at Stanford on EdgeML, and I have some GitHub. Up on GitHub, I have some of the assignments we actually use, with collabs and step-by-step instructions to that people can follow to get all sorts of fun AI things actually running on a Raspberry Pi. But honestly, there's so many good resources out there. It's hard to even remember them all.
Yeah, I would add the TinyML book you wrote as well,
Thank
because yeah,
you.
a sin of omission.
Yeah. I'm not a good salesman.
Nice. And if people want to follow along with you, but also check out the work you're doing at Useful Sensors, like where would you point them, but also how can they be useful to you?
That's a good question. So uh, the first place is I'm a semi-regular blogger at petewarden.com. That's where I try and put most of the news and updates. Um, I would also, especially if you're looking at doing anything in JavaScript, because that's one of our big pushes, is actually being able to run Moonshine quickly and easily in the browser client side. That's something that we're actively, looking at getting into beta over the next month or two. I would love to hear from you. Pete at usefulsensors.com is my email. Just drop me an email if that's an area that you're interested in, and we'll get you on the beta, and we'd love to get your feedback.